Hello, warm greetings to all. In the previous lecture, we created a server, installed the Go ETH client, and initialized the chain data for Node 1. In this lecture, we are going to create a new server and then install the Go ETH client in the same way. But the command to launch the server for Node 2 is different than for Node 1, so let's begin with it. Open the AWS console, select AMI category, and then launch the same template used for Node 1. As step 2 of launch, the console asks to choose the instance type. Here, we'll use the medium server of 4 GB RAM capacity for safety. Moving to step 3 and step 4 of launch, do not make any changes and simply move to step 5, where it asks to add tags with key and value. We'll provide the key value as course-eth-node-2, and will act as name of node 2. Next step, that is, step 6, is to configure security group. We'll use the existing security group with the name course-ethereum, and then click Review and Launch button. In step 7, the console asks to review the instance launch. Click on Launch button to shoot the server. It asks to either select an existing key pair or create a new one. Here, we'll use same key pair for login and launch the server. Now we'll move to our launched instance. Now you can see Node 1 and Node 2 with the name prefix course-eth. The status of Node 1 is running, whereas the status of Node 2 is pending, as we have just launched it. At the bottom, you can notice IPv4 public IP address is available now, so we can use it for login. These two windows are for Node 1. One is command interface window of Node 1, and the other is log window of Node 1. We will log in into third window, which will be the command interface window of Node 2. Type the command ssh-i ethereum.pen ubuntu at public IP of EC2 instance. Use the same command. Log in into log interface of Node 2. So in total, we have 4 windows, 2 for Node 1 and 2 for Node 2. Login into the server may take some time as the server is still launching and initializing. You can check its status here. So it might fail for the first time if you haven't waited for the required time, otherwise try again on the failure. Meanwhile, the server for Node 2 is launching. Let's check out certain things through the command line interface of Node 1. You can notice that few modules showing up in the command line interface. These are accessible by us. So, for accessing the modules, just type admin and enter. You'll see certain function names and other information. Such information is quite useful for the development purposes. A node represents the Ethereum node address. To connect to another server, you will require this address. To access this and node data, type admin.nodeinfo.enode and press enter. Remember that admin is a JSON object, so JSON object followed by its attributes is the way to access the data. In the same way, the attribute ID can be accessed. This represents the public key of the node. Similarly, the other information can be also accessed. Moving to the window of Node 2, type Yes to continue. Now, the first step is to install the Go-ETH client. To do so, use the same commands as used in the previous lecture. It is still taking time as server is launching. In the meantime, let's access another module, net. Simply type net on the command line interface of the Node 1. It displays the number of peers. It comprises internal peers as well as external peers based on the threads. If we type admin.peers, it shows the number of peers. Here, it shows null, as we haven't added anything yet. Note that the peer count need not be the same all the time. It may or may not be the same. Once again, type admin.peers. Now it displays its content. You can notice the local address and the remote address the peers are connected to. Sometimes it connects to the server and sometimes it doesn't. So the peers may or may not be equal to what you expect. By this time, the server might have launched and SSH might be successful. Yes, it is. Now, we can proceed with the Go Ethereum client installation. So copy and paste all the 4 commands one by one and execute them. this will install the Go Ethereum client. Once it is installed, create the eth-dev directory and then the genesis.json. Since the installation process is taking time, we can create the directory and JSON file in the log interface of Node 2. Type mkdir eth-dev and then cd eth-dev, and then nano genesis JSON. Do remember the Genesis file has to be exactly the same, %same. You can't have two different set of Genesis files. Now copy and paste the content and save the JSON file. The next step is to initialize the Genesis or chain data. Before that, Geth should be properly installed, which is already installed. You can check by typing the command geth-help in the command line interface of Node 2. To initialize the Genesis, first move to the eth-dev directory using the command cd eth-dev, and then type the command geth-data dir ~/eth-dev/ init genesis.json. This will lead to the successful creation of Genesis block. Now, Node 2 is ready to launch the server. Remember, to launch Ethereum on Node 2, you need different port and different RPC ports. Though RPC is optional, but we will launch it and will put everything in the ETH log, as done for Node 1. Now copy the command for starting the Ethereum node to geth-data dir ~/eth-dev/ network ID 45634 verbosity 3 IPC disable port 3302 RPC port 8546 console 2 ~/eth-dev/eth.log. Let's change background color for Node 2 tabs. Before executing the command, make sure the network ID is the same, but port and RPC port numbers are different. Run the command on the Node 2 command line interface. It will show the console again. Now in the log interface, run the command tail-f ~/eth-dev/eth.log. You can see that HTTP endpoint is opened, but we don't need it. If you type admin on the command line interface of Node 2, all the information related to the admin module will be displayed. Observe that the peer count is null, as the peers are not connected, yet the reason being mining is not started. So let's get back to Node 1 and perform mining. To start the mining, execute the command on the Node 1 command line interface, miner.start brackets. It returns true. If you check Node 1 log interface, you'll notice that it starts generating DAG, which stands for Directed Acyclic Graph. Once it finishes DAG generation, the mining will begin and will display Ether inside the Coinbase address. Since mining has started, we can check the balance. For this, execute the command web3.fromWay start bracket web3.eth.getBalance start bracket web3.eth.accounts brackets 0 end brackets ether end brackets. It returns 0, indicating no Ether at present. Remember, you can list out all available accounts using the command eth.accounts. You can create new accounts using the command personal.newAccount brackets. It will ask you to enter the password. Once you provide it, your account will be created. The created account can be viewed using the command eth.accounts. Note the account 0 is always the Coinbase. You can also change the Coinbase account if you want. We are not going to change it. If we check the balance of the Coinbase account using the commands web3.fromWay bracket web3.eth.getBalance brackets web3.eth.accounts bracket 0 end brackets ether and bracket web3.fromWay. It displays 0 because the mining is initializing and has not started completely, and no coins were pre-mined. If you would have pre-mined any coins, this account would have shown some balance. So in the command used above, we tried to fetch the balance of the 0th account. Bracket web3.eth.accounts bracket 0 end bracket, and converted the Way balance to ether because this actually returns the balance in Way. Way is the smallest unit of ether. 1 ether has 10 to the power 18 Way in it. DAG generation is still taking place. Meanwhile, if we try to perform mining in node 2, it will show the error because the ether base address is not being set yet. Wait for DAG generation to complete. We will proceed further in the next lecture. Thank you.